Alright, in this video we want to take a look at the concept of work in physics. Work in physics is defined as the transfer of energy from one object to another through motion. So it's not like you're doing your homework or I went to work or did a lot of work today. It specifically has to do with an object being moved. So let's take a box over here, and if I push on this box, so I'll give it a push, that box is going, if I put that's the only force acting on it, then I can make that box move. It'll have some velocity that direction, and it'll move a certain distance. I might go from here to here, right? It could be a horizontal displacement in this case. So this is the idea then. What's happening is I push, so here I am, I'm the object to start with, right? That's me. Yay. So I push on it, I'm transferring energy from me to the box, causing it to move that distance at that particular velocity. So I'm doing work to the box. So when we talk about the idea of work itself, we're going to calculate that by saying the force that I've applied to the object times the distance that it moves while I'm applying that force. Both of these have to be in the same direction for work to be done. You can't have something pushing up on it while it's going to the left or right. Those wouldn't be in the same direction. So since I'm pushing to the right and it moves to the right, then I can find the amount of work, I can transfer energy there. If I was pushing it to the right and it didn't go anywhere to the right, but for some reason it was moving up or down, then what I'm doing is not doing work to it. Something else would be doing work to it to cause it to be moving there. So in this case right here, we could look at this push here as the force applied. Say maybe I push with 20 newtons, and let's say maybe have the box move about 1.3 meters to the right here. So if I wanted to find the work that was transferred here, the amount of energy, that's transferred, the work that was done, I'm going to take that 20 Newton force that's being applied to it and multiply it times the 1.3 meters, that distance that it travels. So my work would then be 26 newtons times meters. And so just like we did with newtons, giving different things some names, we refer to a newton times a meter as a joule. It's just a unit of energy named after a scientist, last name Joule, and so we use a capital J for that symbol. So the work that we've done here to this box is equal to 26 joules. So I have transferred 26 joules from me to the box here that I moved 1.3 meters to the side. Okay, well, let's look at one other example here. Let's take another object here and let's lift it up. Let's apply a force to it this way. Let's lift it upward and have it move, say, a vertical distance. Right? We'll have it go up maybe 17 meters. Alright, so we want to figure out the work. So again, it's the force applied times the distance. We know the distance is 17 meters. So we look at work. It's going to be our force times our 17 meters. We need to know what the force is here. And so the object itself, let's say I tell you it has a weight. Right, a weight of 50 newtons. So typically when you lift something, or something is lifted by a machine or a person, typically that lifting is going to be a constant velocity. That's just how most things operate. So you have a constant velocity, which means you'll have no acceleration, which means you'll have zero or no net force. Which means everything's balanced. So the weight, 50 newtons, has to be balanced out by this lifting force. So in this case, the lift is going to be a force of 50 newtons acting on the object. So anytime we deal with any kind of lifting problems in this class, we will look at the weight of the object to determine the force that we're lifting with. Unless we're told differently, that's how we're going to approach these. So when I started the work down here, we said work was the force times the distance of 17 meters. Now we know what that force is. We know that's 50 newtons, like so. And so we take that 50 newtons times 17 meters and we get 850 newtons times meters, which we can just change to joules, so 850 joules. So that's how much work was done here in lifting. Now, if I was lifting it, then that 850 joules came from me. Maybe there was a crane or some other kind of device, a machine, and then the energy would have come from that machine and go into that object. And so as we go through some other ideas of energy conservation, we'll talk about where the energy is coming from, where it's going to, and the fact that it is being conserved throughout this whole process. So that's basically how you deal with the idea of work in physics.